Hello students, now we are going to start your 8th unit of crash course Waves and Oscillation, last unit from your 11th class syllabus. It is Waves and Oscillations. So first we will start with some basic definitions. I will revise you some basic definition. What is periodic motion? What is periodic motion? Periodic motion means a motion which is repeating itself after a regular time interval. See, Earth is at what place at this instant? After 365 days and 6 hours. Again it will be at same place. Again it will start motion in same direction. Where is the minute's hand in your clock? Where is second's hand in your clock? Where is hour's hand is in your clock? All three after a fixed time interval will repeat their motion. So the motion which repeats itself after a regular time interval is known as periodic motion. The periodic motion which is to and fro about its mean position is known as oscillatory motion. Oscillatory motion in a straight line is known as simple harmonic motion. So we have to take care of these all motions: periodic motion, oscillatory motion, then it will become simple harmonic motion when it is in a straight line. So first we will discuss about simple harmonic motion, and in that what is the equation of displacement? See, suppose I am considering one circle. It is a circle. And it is its diameter which is along y-axis. This is x-axis. Diameter along x-axis, and it is y-axis. And the particle P is moving in a circle. At some instant it was at this point, particle P. It started its motion from this point A, and after moving an angle equal to theta, now is it at this position at point B. Particle is at B. The particle P is moving in this circle. But we will not discuss the motion of P. Now see this foot of the perpendicular. It is foot of the perpendicular M. Now think about the motion of M. Particle P is moving in a circle with a constant angular speed, means it is completing one circle every time in a fixed time. Suppose its time period is t. In a t second, if it is started from A, again it will reach at A. In t second, it is completing one circle. One complete circle means in a t second, it is moving an angle 2 pi. So its angular speed means angle moved in 1 second should be 2 pi by t. Its frequency, number of oscillations, number of cycles in 1 second. In t second 1, so in 1 second it will complete 1 upon t cycles. So its frequency, if I am denoting by n, is 1 upon t. Now when P was at point A, where was M? M was at O. From A, if you drop a perpendicular, it will be at O. P is moving in this way, so M is moving in this direction. When P will reach at this point, say C, P will also reach, when P will reach at C, M will also reach at C. When P will start a motion in this direction, it is moving towards now the point D. M will, if you drop a perpendicular from this side, it means again M is moving in downward direction. When P will reach at D, M will be reached at again O, means from where it started its motion. When P will reach at this point E, M will reach again at this point. When P will start from this position to its original position, M will again start towards going back. When P will reach again at A, O will reach at O. Means P is completing 1 cycle on circle and M is completing 1 cycle on straight line. Since P is moving with a constant time period, every time in t second it is completing 1 cycle. So motion of P is periodic motion, but M is also associated with P, so its motion is also periodic motion, but it is moving around O. To and fro motion means oscillatory it is, but since it is in a straight line, so we can see that motion of M is simple harmonic motion. So now we are going to get one expression for displacement for M. Suppose in t second P moves from A to B in how many second? T second. O displaced by a distance y. So displacement of M is y. Maximum it can go M up to the distance which is equal to radius. If radius is A, it means maximum displacement of M is A, and we know that maximum displacement is known as amplitude. Y maximum means A, it is amplitude. On both sides it can go maximum a distance from O, A. So now in t second M reached at this position from O. If this angle is theta, it should be theta. And OP is radius means A. So we can say sin theta is equals to y upon A. It means y is equals to A sin theta. What is theta? Angle moved in t second, since its angular velocity is omega. So angle moved in 1 second is omega, so angle moved in t second should be omega into t. So we can replace theta by omega t. If particle is not starting from its mean position, it means some phase difference is there. So we can use the relation omega t plus phi. If starting from mean position, it is the equation of displacement. Next, if we differentiate this equation, we will get equation of velocity, because what is velocity? velocity is rate of change of displacement. So this implies we should be, you know the differentiation. So differentiation of sin omega t is omega cos omega t. So we got the formula for velocity, omega a cos omega t. But to cos omega t, you can write 1 minus sin square omega t. And what is sin omega t? Y upon a. So for velocity, we got one expression, omega a under root 1 minus sin omega t means y upon a. So take LCM, after LCM a will come out and will cancel this a, and you will get v is equals to omega under root a square minus y square. So it is the expression for velocity. It is the expression for velocity. If you differentiate this v, you will get acceleration. If I am denoting acceleration by f, f means dv by dt. But what was dv by dt? V was omega a cos omega t. So I am using this relation. So it is d upon dt. V means a omega cos omega t. So differentiate this, what we will get? A omega is constant. Differentiation of omega cos omega t minus omega sin omega t. But a sin omega t is y. So I am putting in this place y. So what I got? F is equals to minus omega square y. Since omega is constant, particle is moving with constant angular velocity. So you can say F is directly proportional to displacement. And this equation is a characteristic equation for simple harmonic motion. It means if in any motion acceleration is in opposite direction of displacement, minus means opposite direction, and it is directly proportional to the displacement, then this motion is simple harmonic motion. And if you are writing in this term, F means d to y, double differentiation of displacement. Take minus omega square y in this side. It is known as differential equation of simple harmonic motion. In this way, it is known as differential equation of simple harmonic motion. Now we will talk about the kinetic energy. The kinetic energy in simple harmonic motion is given by, you know that what is kinetic energy? Half m v square. We know the value of v. So half m v is omega under root a square minus y square. We are using this value. So v square means omega square into a square minus y square. Now we try to get the expression for potential energy. We know that work done in this process is stored in the form of potential energy in the system. But what is work? Work is force into displacement. But force is not constant. It depends upon displacement. So we have to take the help of integration. First, what we will do? We will apply force for a small time interval, for a small displacement, suppose dy, and we will calculate work. And by integrating it, we will get whole work. What is F? F means mass into acceleration. Acceleration was omega square into y. Minus was to represent the direction that force is in opposite direction of displacement. It is opposing the displacement. So, what energy you are spending, it is going to be stored in that in form of potential energy. So, to integrate, by integrating of this, we will get whole work. We want to displace this particle from 0 to y. M omega square y dy. M and omega square are constant, take outside of the sign of integration. So, you know that what is the integration of y? Integration of y is y square by 2. So, it is y square by 2. Now, we have to put the limit. So, we will get work done means potential energy expression is equals to half m omega square y square. It was the expression for potential energy half m omega square y square. So, now we will calculate total energy. What is total energy? Half sum of potential energy plus sum of kinetic energy. It is total energy. Potential energy in this case is half m omega square y square. And what is kinetic energy? Half m omega square a square minus y square. It means half m omega square y square plus half m omega square a square minus half m omega square y square. So, what we are getting? Finally, we are getting half m omega square a square. So, it was the expression for total energy, and what you observed in total energy, y is missing. It means it does not depend upon displacement. It is constant everywhere because a is constant, omega is constant, m is constant. So, it means total energy is conserved everywhere, and it is half m omega square a square. So, when we were at mean position, y was 0, potential energy was 0, whole energy was in the form of kinetic energy. And at extreme position, when y was a, kinetic energy was 0, whole energy was in terms of potential energy. Since in a complete oscillation, particle is 2 times reaching at extreme positions, 2 times it is passing through mean position. It means in a complete cycle, kinetic energy is 2 times maximum and 2 times minimum. Same for potential energy, 2 times maximum, 2 times minimum. So, they can ask you, if frequency of oscillation is n, what should be the frequency of kinetic energy or potential energy? In one oscillation, twice it is going to maximum and minimum. So, its frequency is double, means frequency of kinetic energy and potential energy should be 2n if frequency of oscillation is n. Now, very easily we can prove that motion of simple pendulum is simple harmonic motion. Motion of a spring, if you are putting mass, if you attach some mass with a spring and you give some jerk to that mass, and after leaving the mass it will do simple harmonic motion. So, after that we establish some relation. For simple pendulum, it is T is equals to 2 pi root L over G. Now, they can give some variation to problems of simple pendulum based on simple pendulum. They will put the simple pendulum in a lift. We studied about Newton's law of motion. If lift is going upward with an acceleration a, apparent weight is increased, same effect here. If this pendulum is in a lift which is moving with acceleration a in upward direction, t will become 2 pi root over L by g plus a, apparent change in the value of g. If lift is moving downward with acceleration a, t will become 2 pi root over L upon g minus a. What is L? L is the effective length of pendulum, means distance between point of suspension and center of gravity of bob. What we are doing in simple pendulum, we are taking a spherical bob, attaching with a spring. It is simple pendulum. So effective length means distance between point of suspension and center of gravity of this. They can frame one problem based on this concept also. They will say that we have in place of bob one hollow sphere filled with water. If I make a hole in bottom, water is coming out from this hole. What is the effect on time period of simple pendulum? What will happen initially when your bob was full of water, center of gravity was at center point. But when water is coming down, it will start moving in this direction. And when it is half, again it will start in moving in upward direction, because when whole bob is empty, again it should be at its center. So initially the center of gravity was moving in downward direction, so effective length was increasing, so time period was increasing. When it is half empty, now CG start moving in upward direction. So what will happen? Now center of gravity is moving in upward direction. It means again the effective length is decreasing, so its start value of t decreasing, and when it is full empty, time period will remain same. They can give you spring problem. In spring, time period is 2 pi under root m upon k. What is k? K is spring constant. Spring constant means force constant. Force required for unit extension of length in spring, k. But with spring constant, remember these three facts. If you are cutting your spring in n equal parts, if initially spring constant was k, now spring constant of each part will become nk. If you are cutting your spring in n equal parts, spring constant will be n times. If you are adding two springs attaching in a series with spring constant k1 and k2, the equivalent spring constant will be 1 upon k is equals to 1 upon k1 plus 1 upon k2. Just opposite result of resistance which you have studied in 10th class. But if we are attaching springs like this, and spring constant of one spring is K1 and second K2. The equivalent spring constant you can calculate by the formula K1 plus K2. If you are attaching two mass with same spring, then in place of M you have to put reduced mass, and reduced mass is denoted by mu. And what is mu? You can calculate it by formula M1 M2 upon M1 plus M2. If you are taking the mass of spring in account, then time period will become 2 pi root over M plus ms by 3 divided by K. So, if you are going to solve spring problems, these 3-4 points keep in your mind. You will get full marks. So, it was all about spring. Spring and simple pendulum is important. Now, we are moving to how many types of waves are there. We studied in electromagnetic waves. You know that there are basically two types of waves. Waves which required medium for propagation are mechanical waves, which doesn't require medium are electromagnetic waves. Mechanical waves are again two types, transverse and longitudinal. In transverse, medium particles are vibrating in perpendicular direction of propagation of wave, and in longitudinal waves, medium particles are vibrating along the propagation of sound of wave, and sound waves are longitudinal waves. So now the velocity of transverse waves you can calculate by the formula root T over m. T is tension and m is mass per unit length. If you give a jerk to a string which is fixed at one end, the waves produced in these strings are transverse waves. T is tension in a string and m is the mass per unit length of that string. The formula for V is root T over m, and formula for longitudinal waves means sound waves, it is root E upon D, under root coefficient of elasticity upon density. If you are talking about solids, in place of E put coefficient of rigidity. If you are talking about liquid, put in place of this, it is coefficient of rigidity. It was coefficient of rigidity means N or eta. Put bulk modulus in place of E. When we are talking about gases, gases has two type of elasticity, but put E phi upon D. In elasticity, we have discussed that gases has two types of elasticity, isothermal and adiabatic. So put E phi means coefficient of adiabatic elasticity. Actually, when Newton was calculating the speed of sound by experiments, he was using E theta in this place. And what formula Newton gave for velocity of sound in air? It was V is equals to root E theta by P. It was given by E theta by D, it was given by Newton. And we know that isothermal elasticity is equal to initial pressure. When he calculate the speed of sound at room temperature, what he found? It is coming nearly 288 meter per second. But by practical, he got this number nearly 330 meter per second. There were a big difference. So after Newton, Laplace corrected this कि it should not be E theta, it should be E phi. For gases, it should be E phi by D. And E phi means adiabatic elasticity, which is gamma times the pressure of gas. Gamma means Cp upon Cv. So he got velocity in this order of this range. So this correction was accepted, and now we are saying the velocity of sound in gas is under root E phi by D, where E phi is coefficient of adiabatic elasticity. So it was all about velocities.